Hey, Dr. Brumous.
Yes, Dr. Peachman?
Are you still working on Newton's laws of motion?
Yeah, I actually have an example right here. Newton's first law of motion states that an object in motion stays in motion unless an outside force acts upon it. And as you can see, Dr. Peachman, I have another example right here.
Oh, do tell.
Newton's first law of motion also states that an object at rest stays at rest unless acted upon by an outside force.
And I take it that the ball is the object at rest.
Yes, Dr. Peachman, but not for long, because that ball's about to take a slap shot. As you can see, an object at rest stays at rest unless acted upon by an outside force. An outside force. Force.
Well, Dr. Brumous, to help you out in your studies, I've got a few experiments myself on Newton's laws.
Oh, really?
For example, Newton's second law states that acceleration equals force divided by mass, which means that if I tried to move this by myself,
You're not going to get very far.
it's not very easy. But there are two ways to increase acceleration. One is to increase the force. So if you, Dr. Brumous, were to help me, we could move this fairly easily.
Okay.
As you can see, because we increased the force, we also increased the acceleration.
Yes.
The second way to increase acceleration is to decrease the mass. See, if I push this filled up with blocks, it doesn't go very far. But if I decrease the mass, it goes farther. Oh, Dr. Brumous, I've also got an example of Newton's third law of motion.
As do I, Dr. Peachman.
Oh, well, would you like to be a test subject for my experiment?
Would you like to be the test subject for mine?
Yeah, sure.
Okay.
Blow up this balloon. Newton's third law states that for every action, there is an equal and opposite reaction. When you let go of the balloon, the air will rush out in one direction and push against other air, the action. Then the balloon will blow in the opposite direction, the reaction. Now let go of the balloon. The balloon blows in the opposite direction of the air.
Now, Dr. Peachman, you will be my test subject. Now, punch the wall.
All right, Dr. Brumous. Oh, my hand hurts. Why did that happen, Dr. Brumous?
As you said before, Dr. Peachman, every force exerts an equal but opposite reaction. When you punched the wall, you exerted a force on the wall, but the wall exerted a force back. In a way, the wall punched back. What exactly have we learned today, Dr. Peachman?
I think that we've learned a whole lot from Newton's laws of motion.
Exactly. Whether it's from race cars to punching a wall,
Newton's laws apply everywhere. Then the second way to decrease... Then the second way to increase acceleration is to decrease the mass. See, if I try to just push this here, like, Phil... That was awkward. Oh, Dr. Brumous, I've also got some do it again. Dr. Brumous, I've also got some...
Anecdotal.
Dr. Brumous, I've also got an example of Newton's third law of motion.
As do I. Oh, gosh. Oh, stop.
Oh, Dr. Brumous, I've also got an example of Newton's third law of motion.
As do I, Dr. Peachman.
Oh, well... would you like to help me with my experiment?
No, I would not.
Here, blow up this balloon. Blow up this balloon.
You gotta
Blow up this balloon. Never mind. Blow up this balloon. Blow up this balloon. Here, blow up this balloon. Newton's third law states that for every action, there has to be an equal and opposite reaction. So, if you blow up the balloon, and then you let out all the air should blow away from the balloon, which will make the balloon blow away from the air.
Every force exerts an equal but opposite.
Can't. Oh wait, it is playing. I didn't even know that.
Oh my god.